Okay, so now we're going to give it a shot to practice graphing some of these linear inequalities. So there are 3 problems here. I guess I could make one of them more interesting. How about we put a thingy there? Woo, that's amazing. Not really a big deal. But anyway, why don't you try doing these on your own and then come back or pause it or whatever, and then unpause it, and then we'll work them together. So do 1, 2, 3, and see how awesome you are and stuff. Okay, so whooshoo! Let's do the first one. This way. Where are we? Up here. 2 greater than, or x greater than 2y. So we want to solve x is greater than 2y. So the first step is to get it into y-intercept form, which means I want the y by itself. So I'm going to multiply both sides by 1/2, or I could say I'm going to divide both sides by 2. So kind of whatever way makes the most sense to your brain. At this stage, I'm probably just going to divide both sides by 2. And that gives me x over 2 is greater than y. And I'm going to write it backwards and say y is less than x over 2. Now, if I'm really paying attention, I can also say that that's the same thing as saying 1/2 times x, right? Because it's x over 2. If I did 1/2 times x, that'd be x over 1, and I get x over 2. So 1/2 x is the same thing. So I've got 1/2 x. So I'm going to graph this. Now the question is, I've got my slope, which is the number in front of the x, so that's 1/2. But my y-intercept is missing. No, it's not actually missing. It's right here. It's plus 0. So my y-intercept is 0. So I'm actually right here in the dead center. That's my y-intercept. And my slope is 1/2. So it means I go up 1 over 2. Up 1 over 2. And I'm going to connect. Now, naturally, I always want to connect things with a straight line. But if I go back and I look at the problem, it's not an equality. It's a less than sign. So I'm actually going to connect all of these with, what do you call it, thingy? A line. A dash line, yeah. So that's a really ugly dash line. Okay, and then I got to figure out, well, what side of this am I going to, what do you call it? What side of this am I going to fill in? So I'm randomly going to pick a number down here. How about 1, -1? So they'd probably be way closer here. 1, -1, and then I'll pick one back here, so it's back 1, up 1. -1, 1. That's a little confusing because they're really close to each other. So if you don't like it, you can just pick something else. You can pick some, they don't have to match. So I can go, I'm going to go 3 over and 2 down, or I'm going to go 4 backward and 1 up. So that might be easier for you to picture if you're using slightly different numbers. So I'm going to now look, okay, I've got 3, -2. All right, so I have my original equation is x is greater than 2y. So x is, these are all my x's, and these are all my y's. So is x greater than 2y? So is 3 greater than -4? Yes. So this is a happy place. Happy place. So I'm definitely going to include all this. Now, I'm probably, gotten done this enough now that I'm pretty sure that I'm not going to include the other side. But I'm going to go ahead and check it just to make sure, because maybe I did something weird with the math. So let's do the other side, which is -4, 1. So the question is x greater than 2y? Is -4 greater than 2? No. So no, I don't include that side. And that's all there is to that. Beautiful. Alrighty. Next problem was, is x plus y greater than 3? Is x plus y greater than 3? But to graph it, x plus y is greater than 3. Okay, so I'm going to get the y by itself. So let's subtract x from both sides. So I have y is greater than -x plus 3. Woohoo! So my slope, if you'll remember, is -1, because that's like a secret one right here. So again, considering that that's rise over run, got -1 over 1, and my y-intercept is 3. So my little graph, the y-intercept is 1, 2, 3, and my slope is -1, -1 over 1, down 1 over 1, down 1 over 1. Or I could say it's up 1, back 1, however I want to do it. And I'm going to fill this in. Except, again, I really should do a better job. Looks something like that. Okay, but again, since this is not a greater than or equal to, it's just a greater than. So I don't actually want to include the line. I just want to include, like, you know, the stuff, except I'm not very good at this part. The stuff around the line is going to be a really ugly line when we're done, but that's okay because it's free videos. Free videos means they're not always perfect. Okay, so there we go. So that's a start. Now the question is, what side of that am I on? I'm probably going to be on this side. I'm going to use 0, 0 because it's super easy to use. And then, I don't know, pick something out here like 5, 5. So I have 0, 0, and I have 5, 5. So let's check. 0, 0, these are my x's, these are my y's. So for x plus y, 0 plus 0, is that greater than 3? Is 0 greater than 3? No, it's not, so it's not that side. Let's make sure the other side works. 5, 5. 5 plus 5, is that greater than 3? Is 10 greater than 3? Yay! It is. So this is a happy side, and I can go ahead and I can fill it in. And that's my graph of this linear inequality. And it's so beautiful. Got it? You kind of getting the hang of it now? Alright. One more, and then we'll call it. This one's a little weird. It's y is greater than or equal to 3. I'm already kind of y-intercept formed here, right? So it's kind of weird. Question is, what's my slope? What's my y-intercept? So in a problem like this, you have to remember that this is literally saying y is equal to 3. There's actually no x, and if there's no x, that means there's no slope. So you can consider it being like 0x plus 3. So my slope is 0, and my y-intercept is 3. So if I was going to graph this, my y-intercept is right here at 3, but my slope is 0. It means I don't go anywhere. I could say my rise is 0 under whatever, because 0 divided by blah 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 is still 0. So that means that I don't have a slope. It's just a straight line, boring line. So the guy's like a little skier, and he's like, lame, it's a 0 slope, or something like that. I don't know. I'm not good at this. So that's your slope. Now, should it be an equality? So here we have that it's greater than or equal to, so that means I'm going to keep my solid line, because it's not only greater than, it is also equal to. So now I can pick my 2 points. I can pick 0, 0, and then maybe I'll pick 5, 5. I don't know why I like 5, 5. It's just up there. So 0, 0. These are my x's. These are my y's. So I don't really have an x, but is 0 greater than or equal to 3? No, it's not. So that's not part of my solution. If I look at the 5, 5, is 5 greater than or equal to 3? Yay, it is. So that means that everything up here is part of my solution. And when you're graphing linear inequalities, that's about all there is to it.